We're going to start from this. LSP is not about inheritance, it's about behavioral subtyping. Moreover, none of the solid principles says how we should implement them. They state what we should achieve in order to build rock-solid systems. Now, understanding that it's about subtyping automatically unlocks applicability of the LSP in the frontend, just because we mostly use composition over inheritance. Here's what the principle states, and it's definitely not the most clear scene for understanding. Let's sort it out step by step. What does subtype mean for us in the frontend? We mostly use functions, right? And any function implements an interface, declared or implied. So according to the Robert Martin's explanation in his blog post, the implementation is a subtype of an interface. If two functions implement the same interface, then they can be substituted. We will see it in action a bit later. But what does behavioral mean? It means that we should guarantee that subtype works, literally can do everything as supertype and doesn't throw errors, for example. In other words, this is a check that our abstractions were done right. And actually this entire principle is about correct abstractions in our system. So to sum up, we substituted the functions, and if the system continues to work correctly after the substitution, then we don't violate the Liskov Substitution Principle. Now let's take a look at the examples. We have a dialog component. It's quite short and it looks like this one. You probably have seen it previously at the open-close principle. We have a header, content part and a footer with buttons. This is it. So now to the principal part. We have a dialog type. Here it means that it's a supertype. And here's an implementation. This implementation uses this supertype. Now this means that this dialog component is a subtype of this supertype. And we have also a consumer component, our application that simply consumes our dialog component. So by the principle, if we would like to substitute this dialog with any other dialog, we should just create another dialog component that implements this supertype. And that's it. For this demonstration, I have another component that is called xmaxDialog. It's kind of special dialog for some special occasion when we have, for example, Christmas sales. And it's again simple for demonstration purposes, and it has the same structure, header, content and footer. And the structure is the same because it implements the same interface. So basically we can do the next thing. We can use xmaxDialog everywhere where we use our regular dialog, like this. And we need just to fix our import, like this. Okay, another important thing about Liskov Substitution Principle. It's not only adhering to the types in our interface, but it's about behavioral subtyping. What does it mean in practice? In practice, it means that we pass all the props, but we also should make sure that this all works the same way as a regular dialog component. Meaning we can't miss some part can just stop working, because it's the essential part of this principle. It's behavioral subtyping. Behavior should be preserved the same. Okay, it was a quite simple example. Let's try to make it a bit more complex. So, as you've probably noticed in xmaxDialog, that it's very similar to our regular dialog. So let's do this similarity in the code. We can just use our composition. We can import this dialog implementation in our xmaxDialog. Let's do almost everything from scratch. Pass all the props. Header. Content. And footer. But now we, of course, miss one thing. It's the same dialog. It's not Xmax dialog anymore. Let's try to fix this thing. For this purpose, we would need to change a bit our initial dialog component. And we would need to pass another class name. So we would like to extend our dialog type. We would do something like this. What we've just done here, we extended this base type, let's say. And this is our extend. It works like an inheritance, but it's not like this. We extended this type without writing extend as we might write in the interface here. We just did it without this keyword. Right now, our dialog should implement this interface. Okay. So we have some red files. What does this mean? This means we need to pass class names everywhere where it is required. Okay, let's do it optional, for example. And when it's optional, we'll pass some default value. Just to not break our existing consumers. The next thing I'm going to do, not the best for production, so it's just for an example. So Xmax dialog, here we go, and we need to pass our class name. To make it Xmax again. Now the important thing, where the principle works here right now. Previously, our dialog type was a super type, and our implementation dialog was a subtype, and our Xmax dialog was a subtype. Now the thing's going to change, because right now our regular dialog type becomes a super type. So this is right now a super type. Our Xmax dialog becomes to be a subtype of our regular dialog. Now we have a classic relation between parent entity and child entity. So we have a parent stuff that we then extend in our subtype. But we don't use extend or inheritance, we just use our old good composition. So yeah, that works like this. Next, let's use our Xmax dialog in our consumer. Can we substitute? Yes, we just did it, and it has the same typings, so nothing failed here, and it should work just the same. How we guarantee that it works the same? Just because we pass the same props into the parent dialog component. That's it. We are adhering to behavioral subtyping. That's fine. What about the more complex example? First, we have a parent-child relation right now, and we would like to make more complex our app component. How? Let me show you. Let's import again dialog component. And what if we would like to change implementation of the dialog due to some condition? Okay, let's say we have some sales season. It's of course Xmas in our case. So I have some helper. I have an app store. Let's utilize it. Okay, we would like to have a condition, and our condition will define which actual implementation we'd like to use. Component variable, and App Store has sales, and let's write an occasion. It's an Xmas occasion, and a ternary operator. So if it's Xmas, then we would like to use Xmas dialog. Otherwise, it's a regular dialog. Oops, we need to import. Fine. And now, final result. No TypeScript errors, and for specific occasion, we would have just Xmas dialog to work for us. That's it. Thank you for watching, and see you in the next videos.